Hi there, today we're going to be talking about adding linear expressions as well as subtracting linear expressions. So here we go. It's kind of a carryover from the last lesson where we were combining expressions and simplifying them, and we were doing a little bit of adding anyways, but now it becomes a little more official. And so I want to just show a couple of examples they have here just to kind of help you work with it. One way they teach this oftentimes is to show it with models. Models means to rewrite these terms in terms of like, okay, instead of 3x, let's draw it out as three boxes that are called x, and then we take our coefficient here, or our constants, our 5, and we go 1, 2, 3, 4, 5, and break it apart. And then if you do that a couple times and do it for the 2x plus 3, then you combine the things that are alike. What we were doing before is we were essentially saying, let's combine like terms this way. Let's take our 3x and our 2x and say, okay, let's put those together. 3 plus 2 becomes 5x. And then let's take our constants here of our 5 and our 3, and we say 5 plus 3 is 8, and it's 8, and we just worked them like that. The model is a way to help you visually understand what's going on there, but it's not required at that point. So it's not like something you have to do. So you don't have to worry about making a model unless the model helps you understand what's going on. The modeling is probably more beneficial when you're talking about subtraction and what happens to these terms. Because in this case here, you can see we have an x and we have a minus 2, so they draw it as an x box, and then we have a minus 1 and minus 2 for minus 2, minus 1 and minus 1 for minus 2 altogether. Then over here we have negative 2x, we have a negative x, and then we have 4 as a constant, 1, 2, 3, 4. So now when you combine the x's together, it looks like this. And you can see with these x's here that this positive one and this negative one essentially cancel each other out, so that all you're left with is just this one negative one there, which becomes a negative x. And when it comes to the constants, we have the two negative ones there, the 4 negative ones there, and this negative cancels that positive, negative cancels, and we're left with just 2 right there, which again you can see, and it flows down to get the 2 there. So the end result is a negative x plus 2 as the solution. Again, you could just simply look at the like terms, x and negative x. This is a 1, right? 1x. So negative 2 and a positive 1 becomes a negative 1x. And then a negative 2, or draw it with a triangle maybe, a negative 2 and a positive 4. Difference there. 4 minus 2 is 2, and it's positive. And you end up in the same place. So the modeling is just a way to help you see what's going on if you're not able to kind of group your like terms and add and subtract them effectively. So a couple examples here before we jump to subtraction. In this case here we have 5x plus 2 plus 3x plus 1. Because this is all adding, we can leave it like that. Later on, when we go to the next page for subtraction, I'll show you it's probably best to rewrite it as 5x plus 2. Let's get rid of the parentheses and say that's going to be 3x and a plus 1. At that point, we're going to combine like terms, 5x and 3x, and here I have a 2 and a 1. So 5 plus 3 is 8x, and 2 plus 1 is 3, and we leave it just like that. If I'm looking at negative ones or negative numbers, again, I could rewrite this as negative 8x plus 1 plus, I could say negative 2x, right? Negative 2x, and then plus 6. So I have a negative 8x and a negative 2x. So those combine to give me what? Negative 10x. Then I have a 1 and a 6 combined to give me a 7. So when you're adding the expressions, it's pretty straightforward for what we're going to do. Where it becomes a little more complicated, where you want to just be careful, is when we switch over to doing subtracting of linear expressions. So with linear expressions, when we're subtracting them, we do want to think of what is called the additive inverse, which means, like we talked about before, when we were doing integers and we had 5 minus 3, we talked about saying, instead of doing subtraction, we said let's add the opposite, or add the inverse. That is the additive inverse. So whenever we have a subtraction problem, we convert that problem into an addition problem. That is what the additive inverse actually is. So when we have an example like this, when we rewrite this one, we would say, well, that's a minus 3x minus 2, but instead of minus 4x, we're going to do add the opposite. So we're going to add negative 4x. Okay? So in this case here, what I'm left with then is a minus 3, minus 2, and then also, in this case here, a minus 4 as a way of kind of getting that minus sign away from that. It's still a little funny because we just still have the one parentheses there, not a big deal. So in this case, we have minus 3x minus 4x, which will combine to give us a minus 7x, and then we still have a minus 2 right there. So we would say minus 7x minus 2. Okay? Be careful then with example number 2. This is where kids tend to make mistakes. The first part is easy to rewrite, correct? You would just say, okay, 4x plus 6. But when I add the opposite on this side for this part right here, remember this becomes add the opposite of plus 1 is minus 1. So I end up with plus 7x minus 1 like that. Okay? So it's a little different there. Now, what I'm doing is I've been just kind of grouping our like terms and then combining them. So 4x and 7x becomes 11x, and 6 minus 1 becomes 5. What they're showing you here to do is kind of like stacking, to arrange them in columns and say, well, there's 4x plus 6, and here's 7x minus 1. Now let's add it up this way, 7 plus 4, and 6 minus 1. You still end up with 11x minus 5, 11x minus 5. So whichever way makes sense to you is good. I think that realistically, you want to be able to start doing it more like this, just so it's fast and simple when you start working out longer equations. You're probably not going to want to start stacking them up and reorganizing that way. This is one more step of writing things down. It's probably just faster just to do it like so. A couple examples before you jump into your homework. So here's number 1. Let's rewrite this using the additive inverse. So we say 9x plus 10. Now we're going to add the opposite. So we're going to say plus a negative 2x, and then we're going to say plus a minus 4. Okay? So that's how we take care of that subtraction problem there. So now I have a 9x and a negative 2x. 9 minus 2 is 7x. And here I have a 10 and a minus 4, and 10 minus 4 is 6. So we'd say 6x for that one right there. Let's take a look at number 3. Again, rewrite this here. We have 6x plus 3. Now let's add the opposite. The opposite of negative x is x, and add the opposite of minus 2 is a plus 2. So we have 6x and x, which becomes, again, 7x. And then we have a 3 and a 2, which becomes 5. So that's the basic idea of what you're doing today. So we're going to do several problems like this one. And in fact, today's assignment actually says to do, well, it says just to do the odds. So we're going to do the odds on this next page, which looks something like this. We're going to work on the odds on this page. Ooh, there it is, right there. All right, I'm going to pause here, let you start on your homework. I'll see you back here in just a minute. All right, here we go. Let's work these out. All right, so rewriting them, we would say 3x plus 5 plus 5x minus 2. So combining like terms, we have 3x and 5x, which becomes 8x. And then we have 5 and minus 2. 5 minus 2 is 3. So we have 8x plus 3. Over here, rewriting it again, we have 6x plus 6. And then we have a plus minus 3, which is like basically, well, we can write it this way, plus minus 3. And then we're going to add a minus 4x right there. Combine like terms, I have 6x and minus 4x. 6 minus 4 is 2x. And then I have a 6 and a negative 3. 6 minus 3 is 3. So we'll leave it like that. Next one, we have 6p plus 4, straight enough, plus negative 5p plus 8. We're just adding, so it's not the additive inverse, it's just like that. So 6p and a minus 5p. 6 minus 5 is simply 1. I could write down 1p, but you just need the p. Now I have a 4 and an 8, and 4 and 8 together make 12. So you could also say p plus 12. Both of those are fine. For number 7, all right, we have a negative 8r plus 8, and then we're going to add a minus 7, and then we're going to add a minus 7r. So I have minus 8r and minus 7r. Combine those together and we have a minus 15r. Because the signs are the same, I find the sum and keep the sign the same. And here I have an 8 and a minus 7. When the signs are different, I find the difference and keep the greater absolute value sign, which is going to be positive in this case. So 8 minus 7 is 1, so a positive 1. For number 9, we write this. We have 1 minus 6x plus 7x plus 3. Like terms, we have a minus 6x plus 7x. Signs are different. Find the difference. Keep the greater absolute value sign. So we have a 1x. And then over here we have 3 plus 1 is 4. Or we can just write x plus 4. Alright, number 11, we have negative x minus 3 plus 3x plus 8. Like terms, 3 minus 1x is 2x, and then minus 3, positive 8. Combine those integers, they are different. Find the difference. 8 minus 3 is 5, and keep the greater absolute value sign, which is positive right there. And number 13, our first subtraction one of the whole thing, just because of how it worked out, probably should have had you do some other ones, is negative 2 minus 5v. Going to add the opposites. We're going to add, instead of a negative 4, we're going to add a 4v. Add the opposite of negative 2 is plus 2. So now we're going to group minus 5v and plus 4v. Negative 5, positive 4, works together to be a negative v, or just 1v. And here we have a minus 2 and a plus 2, which becomes 0. So my answer is simply minus v. Okay? I'm going to do one more just real quick just to make sure you got the hang of it. So here's one that if you want to try one more minus 1 on your own real quick to see if you can do it. Pause real quick, do number 12, and then see if you get the same solution I have. Here we go. Number 12. 7 plus a. Let's add the opposite. Add the opposite. This becomes plus 7a minus 1. So now we have an a, 7a becomes what? 8a, and a 7 and a minus 1 becomes plus 6. Alright, that's it for today. Hope you're getting the hang of that. Again, this is just some review work from junior high school. Hopefully this becomes more just natural for you and you're able to kind of fly through it pretty quickly without making any careless mistakes. That's it for today. Have a great day. We'll see you next time.